You know we are simultaneously live on YouTube.
Yeah.
Okay. So today we are going to discuss the center of mass, and after discussing center of mass we'll discuss collision. But today in our class the main topic will be center of mass. Are you aware about center of mass? What is center of mass?
Center of mass is the point from where the where we can consider that the mass of the object is concentrated, and we can do calculations to get the correct result.
Okay. That means if you hold a book in your hand, okay,
Yeah.
and you can balance
You
it.
can hold it at one point and it
Yeah,
still
you can
balances
hold it
itself.
at one point, so that means it is a center of mass of that particular book. Is it?
Yeah.
Okay. Just a moment. Just a moment. Okay. So, center of mass is just a, you can say it's a point where you can say that the whole mass is concentrated on that particular point. So, that is called as center of mass. Okay. So, we will discuss, yeah. So, for a system of particle, center of mass is that point at which its total mass is supposed to be concentrated. Okay. So, let us say this book. Okay. So, ideally if it is a regular body, so the center of mass will be there if you draw a line across this and if you draw a line across this. So, where these cutting each other, that will be the center of mass of this particular body. Okay. But it is a regular shape, it is a regular body. Regular body means it has some line of symmetry. Okay. So, we will discuss that. So, that means the entire mass, we can imagine that it is concentrated into the center of mass. Okay. So, if we hold it like by a finger, so it will balance, isn't it?
Yeah.
Okay. So, the center of mass of an object is a point that represents the entire body and moves in the same way. As the body is moving, so center of mass will also be moving. Okay. So, point mass having equal to that of object when subject to the same external force that act on the object. Now, if you have two particles, okay, let us say you have two particles, that is M1 and M2. Let us say earth and moon, okay, earth and moon. So, what is happening? Earth is rotating.
Earth is always rotating, right? The moon is revolving around the earth.
Yeah, moon is revolving around the earth, but earth is rotating on its own axis. Okay. So, when moon is revolving around earth, so they are bound by a gravitational force. Okay. So, where the center of mass of these two bodies lying? At a fixed distance. It is not in the middle, because masses of these two bodies are different.
Okay, so it will be more towards moon.
Yeah, if
It will
mass,
more towards earth. Moon will have more.
yeah, if more mass, so more attraction. Okay, lesser mass, the lesser the attraction. Got it? So, let us say two particles, that is M1 and M2. So, where their center of mass will be lying? So, the position vector of mass M1 is, let us say it is R1, and position vector of mass R2 is M2. Do you understand what is position vector?
Yeah.
Okay. So, let us say your position vector R1 is A1, B1, C1. Okay. So, let us say your R1 is A1I, A2J plus A3K. Okay. Or generally we write it like A1 A2 and A3. We can also represent your vector like in this format also, that is A1, A2 and A3. Okay. And your R2 vector is, let us write it, B1, B2 and B3. So the center of mass will always be lying, if you have multiplied M1 with R1 and just add it with M2 R2 and M1 plus M2, you just have to divide it. Okay. So that will be the center of mass of these two bodies. So somewhere here it will be lying. Okay. So just write down the formula. If you want to find center of mass of certain bodies, so that will be given by M1 R1 plus M2 R2 upon M1 plus M2. We'll use it.
So this will give the position vector of the center of mass.
Yes, it will give
With
you the,
respect to origin.
yeah, it will give you the position vector of center of mass. Okay. For an example, if you have taken like let us say it is your 2 kg mass, that is 2 kg, and here it is 3 kg of mass. Okay. Let us say it is M2, and with respect to origin, let us say, so the vector of this mass and the vector of this mass. So let us say this R1 is 2I plus 3J plus K. Okay. And this vector is I plus 2J plus K. Got it?
Yeah.
Now find the center of mass of these two bodies. Just do it.
So it will be. Let me start the diagrams here.
Yeah.
We need to simplify it as well.
Yeah. Why you are taking too much time here?
It's taking a lot of time to simplify the root.
That's very simple. Why are you taking root? There is no need to have root.
But can't just take the vector value of r, right?
Yeah, it is simply just you have to multiply m1 with r1. So what will be m1 r1? m1 r1 will be 4i plus 6j plus 2k. Is
We'll just do it with the vector value.
yeah, m1 is a scalar quantity, r1 is a vector quantity. If you multiply that only the scalar one is to be multiplied.
No. What I did was I found out the magnitude of r1. That's what.
Why? What is the need?
I don't even need to do it.
You just put it into that format. Okay. So m1 r1 would be 4i plus 6j plus 2k. And what will be the value of m2 r2? m2 r2 will be 3i plus 6j plus 3k. Just add these two and divide it by m1 plus m2. Simple. Okay. So what will be summation mr? Summation mr will be ii is just add it 7i plus 12j plus 5k. Okay. And just divide it by this mass combinedly. So if you divide it by 5, so by m1 plus m2, so that will be 7 by 5, 12 by 5, and that 5 will be only, that will be only k. So that is your coordinate of center of mass. Isn't simple?
Yeah, it's good.
So why you made it complicated?
I'm trying to find that magnitude.
No, you need to find it magnitude. Okay. So it may be depending upon whether it is given in 2-dimensional or in 3-dimensional. If it is in 2-dimension, only x1 and x2 will be there. If it is in 3-dimension, y1, x1, x2 and x3 will be there. Okay. So they are talking about 2 dimensions, so only 2 dimensions we have considered. Okay. So basically, okay, if origin is the center of mass, then what will be their coordinate? 0, 0. Simple.
What?
If origin is the center of mass,
Okay, it will be 0, 0.
so that coordinate will be 0, 0. So that means m1, that RC will be 0. So if RC is 0, so m will go there, that will also become 0. So that means their summation of m and r will be 0. Okay.
Yeah.
So that means
What's that x and y components, sir?
x and y component will be different.
No, what's this xc by c1?
Which one?
This xc is equal to, what's that?
Yeah, xc, that they have divided into magnitude in x direction, it is a magnitude in x direction, it is magnitude in y direction. Okay, like we found it, it was like previously we found it RCM, center of mass, we did it 7 by 5i plus 12 by 5j and plus k. So what is its x and y? So this is its x coordinate and it is its y coordinate.
Okay, so basically just that.
So that is z coordinate. Okay.
Okay.
So they have done it separately, that xc means the abscissa of x, the center of mass. Okay. This is the ordinate of center of mass. That means it is x value, that 7 by 5 and 12 by 5 is the y value. Okay. Got it? Any doubt? Okay, very nice. So since neither of masses m1 and m2 can be negative, to satisfy the above equation, vector r1 and r2 must have opposite signs. Okay. So if m1 r1 plus m2 r2 is 0, so what happens? It can't be 0 until and unless your R1 and R2 they are in opposite direction.
Yeah.
Okay. So to make it 0, either R1 or R2 must be negative. Got my point?
Yeah.
Okay. So if origin, let us say this is your center of mass. So that means one mass will be, both masses, the origin will be in between these two masses. Okay. That means one mass will be on this side, one mass will be on the other side. Okay. If center of mass is origin, in that case that will happen. Okay.
Only if center of mass is origin.
Origin. Got my point?
Yeah.
Okay. So, and if it is 0, if m1 r1 plus m2 r2 is 0, so that means m1 r1 will be equal to m2 r2, then only it can be 0. It is,
Yeah.
it is its numerical value. We are just considering its numerical value. So numerical value will be equal, and it will be vectorially it will be opposite. Okay.
Yeah.
But numerically it will be 0. So if numerically they will be equal. So if they are equal, then this is the conclusion. So R1 by R2 will be equal to M2 by M1. What is R1 and R2? R1 and R2 are the magnitudes of the vector R1 and R2. Okay. So that R1 and R2 are the magnitude of two vectors, and M2 and M1 are the masses of two vectors. Just you can see that R1 by R2 equal to M2 by M1. It's a reverse ratio. Okay.
Okay.
So just write it down because it will work.
But this is only when they are in opposite direction.
Yeah, no. If the origin is center of mass, if the center of mass is origin, in that case your R1 by R2 will be equal to M2 by M1.
But even if it is not origin, it's like only line perpendicular to the y-axis or perpendicular to the x-axis. Then you would, and the R1 and R2 are equal. Then it would still be valid, right?
Yeah, it will be still that will be valid. Okay.
So like this can be. Why do you only say origin? So it should be like applicable for the when they're in opposite direction and of equal magnitude. Right?
Yeah.
It work for both cases.
Yes. Okay. So we conclude that the center of mass of the two particle system lies between the two particles on the line joining them, which divides the distance between them in the inverse ratio of their respective masses. That means R1 by R2 will be equal to M2 by M1. Okay. So let us say these are two particles M1 and M2. Okay, and let us say the center of mass is here in between these, the joining of these two particles. So the center of mass will be always lying on the line which are joined, which is joining these two masses. Okay, let us say the distance of center of mass from mass M1 is R1, and the distance of mass M2 is R2. Okay. So what will happen? Since center of mass of two particle system lies between the two particles on the line joining them, which divides the distance between them in the inverse ratio of masses of the particle, we can write so that R1 will be equal to M2R divided by M1 plus M2.
Can you explain this again, sir? I don't understand this section.
Actually, this is nothing actually. You just have to use that above formula. Okay. What was above formula? So the center of mass, the coordinate of this center of mass, let us say it is x1 and y1, xc and yc. Let us say this is xc and yc. Okay. So what will be the value? X.
So it will be M1x M1xc divided by M1
See, in this scenario, let us say this is x-axis, okay?
Yeah.
So on x-axis,
So y will be 0.
y will be 0, okay? So that means what will happen? If you just put that values in this formula, what will happen?
Okay, so y cannot be 0, so it will only become but sir, shouldn't it, I don't understand still, why shouldn't they write according to above formula, they should have written m2 x2 plus m1 x2 divided by m1 plus m2, right?
Yeah, but that was R, okay? They have written it in a reverse order. Just don't mind it, okay? You need not to remember this one.
Okay.
Got it? So now center of mass of several particles, the same thing will be happening here also,
Yeah.
okay? So you just need to multiply m1 with the position vector of m1, m2 with the position vector of m2, m3 with the position vector of m3. You just have to add all these, okay? And you just have to divide with all the masses. So that will be your center of mass. So nothing is going to change here. If it was 2 particles, then only we were adding m1 r1 plus m2 r2, okay? So it's a system of several particles. So nothing is going to be changed. The same thing will be happening.
Yeah.
Got it? Once we'll do some questions, that you will understand it. Now, if we're talking about center of mass of continuous distribution of mass, continuous distribution of mass means, let us say, it's not a regular shape, okay? Like, if you are talking about this mouse, okay, it's not a regular shape. There is no line of symmetry of this shape, okay?
Can we do this center, right?
Yeah, it is narrow here, it is thicker here,
Yeah.
okay? So, for this type of systems, so but it's a continuous distribution of mass. Continuous distribution of mass means wherever you are going, you will get same mass over a particular area, okay?
The mouse, like the front part is narrow, right?
Yeah, front part is narrow, but if you talk about a particular volume, so that volume, same volume will have the same mass. If it is a 3-dimensional figure, if it is a 2-dimensional figure, so same area will have same mass, okay? That means, let us say this is a 2-dimensional lamina, okay? So, if you have this area as 1 meter square, okay? This area is 1 meter square, and this area is also 1 meter square. Got it? So what will happen?
So both of these will have the same mass.
Yeah,
basically.
both of the areas will be having the same mass. That is the meaning of continuous distribution of mass. Okay? If it is a 3D figure, that means same volume, same mass. Okay? Got it now?
Yes.
Okay, just note it down. Then RCM will be given by this. RCM will be the position vector of center of mass will be given as, just you have to make integration of dm. Okay.
What's RCM? You didn't explain.
RCM is center of mass, the vector of center of mass.
No, what is so basically radius of the?
It's not radius, yaar.
It's an irregular object.
It's a vector. It's a vector.
What vector is it?
It is a center of mass vector. Somewhere it has center of mass. Let us say here. So the position vector of this center of mass is RCM.
Okay.
Okay.
It's a position vector.
Yeah, it's a position vector of center of mass. Got it?
Okay.
Just note down this formula because it will be used. Okay. So that RCM equal to 1 by m of RDM.
Okay.
Okay. R is again the position vector. Small r is again the position vector of small mass. Okay. That is dm.
Okay.
You will understand once we will do questions. You will understand that.
I need to note that down.
Okay. Please note it down.
What's the heading for this?
It is the center of mass for continuous distribution of mass. If you have continuous distribution of mass, then center of mass will be calculated by this formula. It is 1 by m integration of r dm. Just wait for a moment. Okay, understood? Understood, Vihan?
Yes, sir.
Okay. Now center of mass of composite bodies. Let us say two type of bodies you have. This one is circle, this one is square. So now what will happen? How to find the center of mass of these two bodies? So again we'll use the concept of two bodies. Okay. Where the center of mass of this body is, as it is a regular shape, so center of mass is at the center, isn't it? So we can consider the entire mass of this body is lying here.
Okay.
Got my point? And the center of
Okay.
okay, and the center of mass of this square will be lying here,
Yeah.
isn't it? So that will be, you will consider it as M2.
Okay.
So now don't think it like it is a circle, it is a square. So just think about that,
It's a system.
that you have M1 here and M2 here. Got my point?
Yes.
So the first thing is to find out the center of mass of the body and find the center of mass of other body, and then consider these two masses as a system of particle. Okay? That is a simple technique. Got my point?
Yeah.
Okay. So now, if you denote the surface mass density, what is surface mass density? It is mass over area.
Surface mass.
Okay?
Okay.
Surface mass density is, just write it down, surface mass density is mass over area. Okay, so it is mass of per unit area. Got my point?
Yeah.
Okay, so if your surface so that is denoted by sigma. Okay, so what will be the mass of the disk now? Mass unit per unit area into area. If you multiply this by area, so what will happen? It will become mass, isn't it? And your mass upon area is rho, and this is your area. Got my point? So mass is always equal to surface mass density into area. Just write down this formula. Okay.
One second.
Note it down.
One second.
When is your exam for center of mass?
Sunday.
Sunday. That means we have 5 days still. Okay, we'll try to finish it on Friday.
It's center of mass and circular motion and NLM.
Okay, all the 3 topics.
Yes.
Okay. So the location of center of mass, let us say it is your XD and YD. They're talking about the disk. Okay. This circular one is the disk and this square one is the plate. Okay. So let us say the center of mass of this disk is XD, YD and the center of mass of this plate is XS, YS. Okay. So these 2 points are given to you. You have found the masses of the disk and masses of the plate. So the same concept can be used, whatever we discussed previously. So we will consider these two as a 2 body system. Okay. So that is the same thing we did previously, isn't it?
Yeah.
Okay. If they have the
Understand what's the difference between the composite body and like
composite body means it is a combination of different type of shapes. Okay.
will it solve it the same way?
Yeah, that will be solved in same way. First of all, you will find the center of mass of first body, then the second body, then the third body. Then you will find its coordinate, that means the position vector. Okay. You multiply mass with the position vector, add all these MR, okay, and divided by all masses. So, we will get the position vector of center of mass. Got it? So, that is the same thing. If density is equal, then what will happen?
Density is equal. Then it will be same.
If density is equal,
Yes, it's
if this one is equal for both the system.
Yeah, exactly right. Yeah, how will it change anything if it's equal? I'm confused.
Confused. If they have the same density, then if surface mass density, they also have the same surface mass density. Okay, we have considered as a sigma. Okay. Okay, we'll see that once we'll do questions. Now it is a truncated bodies. Truncated bodies means we have taken a part of something. Okay. Then in the similar fashion we'll do that. Got my point?
Okay, we'll imagine the part which is cut and then imagine it as a separate body and then store it, right?
Yeah, and then we will subtract it.
Okay, we won't add it because the mass has been removed from the
See,
main
first of all you have to find the center of mass of entire body.
Yeah.
And then find the center of mass of this body, whatever is removed.
Okay.
And then subtract from this one.
To find out one of the subtender.
Yeah. So xcm will be mx minus mx dash. What is x dash and y dash? X dash and y dash are the center of mass of this eliminated body. Okay. That's why we took it minus. Got my point?
Yeah.
So rather than adding it, we'll subtract it. So mx minus mx1 upon m minus m, and it will be my minus my dash upon m minus m. If it is a 3D figure, then z will also be coming into the picture. Okay? That is simple. Okay. Center of gravity, what do you think about it?
Center of gravity.
It is different. Sometimes it is different than the center of mass. Okay. Center of gravity is because of gravitational force of earth. Okay. That means the weight of the body acts on it. But in case of center of mass, the entire mass of the body is positioned at the center of mass. Okay. So that is the main difference in these two. Okay. Now golden key points. Center of mass may be inside or outside of the body, and it may be on the body. For an example, this is a semicircular disc. So it has center of mass here. It is outside the body, isn't it? It is circular disc. It is having center of mass here. It's not on the body. So these are the things in which the center of mass is not lying on the body, but it is away from the body. Okay?
Yeah.
Isn't it? So there are some points. So there may or may not be any mass present physically at the center of mass. Got my point?
Okay.
So these are some examples. Center of mass may be inside or outside a body. You can see here, it is outside as well as inside of the body. Position of center of mass depends on the shape of the body. It depends upon shape of the body. For a given shape, it depends on the distribution of mass within the body and is closer to massive portion. Okay? It is also closer to the massive portion. You can see here, it is the massive portion here, so it is here. So that is more closer to the massive portion. For symmetrical bodies having homogeneous distribution of mass, it coincides with the center of symmetry or the geometrical center, if it is a regular shape. Okay?
Okay.
So these were the some key points. If we know the center of mass of parts of the system and their masses, we can get the combined center of mass by treating the parts as particle placed at their respective center of mass. As I told you, if we have so many masses and we have vectors of these masses, so we can calculate the center of mass of the entire system. Okay. So it is independent of the coordinate system, that is the center of mass of a ring is at the center whatever be the coordinate system. If the origin of coordinate system is at the center of mass, then I told you this one, it's M and R. What is M and R? M, if R is multiplied with M, so what it becomes? We'll see it later. Okay, so it is said to be the moment. It is said to be movement. No movement, moments. M-O-M-E-N-T-S. Okay.
I don't understand, sir. What did you just explain?
M-R, the multiplication of M with R is said to be the moments of masses.
Remember?
R, the position vector.
Minus- Okay.
If we multiply mass with the position vector, so that becomes moments of mass. Okay,
Okay.
got my point?
Okay.
Okay, now we'll see center of mass of some uniform. Let us see some questions first. Okay,
Okay.
whatever we discussed up to here, we'll do some questions. Yeah, this one. Just try to do this question. So here the three bodies of equal masses, let us say M are the masses of these three bodies. And the coordinates of each body is also given. You need to find the center of mass, the coordinate of center of mass. आवाज कम कर दे टीवी की नहीं उधर जा किचन में जा इनमें जाके चल Done? We are done?
No, sir.
Why? It is very simple, yeah.
One second.
Just find the movement of each particle. Add it and divide it by masses.
Getting it in terms of A.
Yeah, it will be in terms of a. What do you got it?
Yes, sir. equals to
Yeah, please.
2a
2a.
plus a root 3
2a plus a root 3
divided by 12.
divided by 12. Okay, that means a by 6. In terms of coordinate, it will be I and j. That is the, you're talking about the vector, isn't it?
Yeah.
So that will be the, if I talk about the coordinate, so that will be 2a by 12 and a root 3 by 12, isn't it?
Yeah.
So that will be
Okay.
a by 6 and a root 3 by 12.
12.
Okay, simple it is.
Yeah.
Okay, very nice. So like this we can, yeah, it is wrong here. It must be a root 3 by 6. It must be a root 3 by 6. You said it 12. Okay, just I'll tell you. So your RCM would be, this will be multiplied by m. Let us say the mass is m, its mass is also m, its mass is also m. So if you multiply this one with m, it will be 0 plus multiply m with a 0. So that will be MAJ, sorry, MAI it should be, isn't it? J part is 0,
Yeah.
okay, and plus a by 2i multiplied by m plus m a root 3 by 2, j it should be, divided by how much? M plus m, isn't it?
Yeah.
Okay, so cancelled from numerator and denominator.
Yes.
So that is, if you add this one, as it's an I component, so a plus a by 2, it is 3a by 2 divided by 3, m plus m, it will be 3m, cancelled. Okay,
Well, how did you get 3a by 2? Okay, nothing.
a and a by 2 is 3a by 2. Okay, plus this is your a root 3 by 2 j, isn't it?
Yeah.
So if you writing this system into coordinates, so that will be the first coordinate.
Yeah.
That means it is x coordinate. So you will write it x cm equal to 3a by 2. Sorry, why it is 3? Yes, right. 3a by 2 divided by 3. 3 cancel, so it will be a by 2. Okay. And ycm, that means the y coordinate will be equal to a root 3 by 2 divided by 3. So that will be a root 3 divided by 6, isn't it?
Yeah.
So the coordinates will be a by 2 and a root 3 by 6. Okay?
Yeah.
Do you understand it?
Yes.
Okay. So that's why it is a by 2 and a root 3 by 6. Okay. Can you do this one?
Yes, sir.
Let's try it.
2, right?
Yeah, 2. Calculate the position of the center of mass of a system consisting of two particles of masses m1 and m2 separated by a distance L. Okay, you need to decide the coordinates.
Okay.
Coordinates will be 0, 0 and L0.
Yeah.
Okay, just find its center of mass.
Okay.
moment of m1 will be 0
Yeah.
and the moment of L2 will be m2 L2 I, J part would be 0. Okay, just do it at your own.
Done.
Done. What is the answer?
We need the coordinates of the.
Yeah, what is your answer?
It is m1 0 plus m2 L divided by m1 plus m2 I cap.
Yeah, so I have you multiply m1 with 0 0, so that what is the value? That will be 0.
Yes, it will be m2 L divided by m1 plus m2 I cap.
Yeah, you are right. Okay, so what will be its
And the y
coordinate?
would be
What
0.
what will be its coordinate?
m2 L divided by m1 plus m2.
m2 L m2L divided by m1 plus m2
I cap.
and 0
0.
and 0. Okay, because it is on the x-axis, so y will be 0. Got my point? How to draw these things? Got it? So xcm is m2L divided by m1 plus m2. So these are some questions, you need to do it at your own. This just write it down. Illustration number 3. Just write it down. Illustration number 4.
Illustration 3, 4.
3, 4, 5. Okay, that's very important one. Fifth one is a very special question, very important. Some part is eliminated from that disk. Okay, then illustration number 6, 7 also, 8, 9, and this is beginner box. You have to do the entire one, this exercise. Okay,
Every question to exercise it is
yes,
to write.
yes.
Okay.
Okay, then we'll meet you tomorrow.
Okay.
Timing most probably that will be the same.